Have you ever thought about our planet's address in the vast, sprawling city of the Milky Way galaxy? It's not just about being in the right solar system, it's about being in the right neighborhood around our local star, the Sun. Scientists have a special name for this perfect little strip of space, the habitable zone. But you might know it by its more fairy tale-like name, the Goldilocks zone. This name comes from the classic story of Goldilocks and the Three Bears. Remember how she tasted 3 bowls of porridge? One was too hot, one was too cold, but the third one was just right. Our planet, Earth, sits in a region around the Sun that is also just right. It's not so hot that all our water boils away, and it's not so cold that it all freezes into a solid block of ice. It's the sweet spot where liquid water can exist on a planet's surface, and that, my friends, is the secret source for life as we know it. This concept isn't just a quirky name. It's a fundamental principle astronomers use when they search for life on other planets or exoplanets. They look for stars similar to our Sun, and then try to spot planets orbiting within that star's Goldilocks zone. So what if our planet wasn't so lucky? What if, through some cosmic fluke or a gravitational nudge from a passing celestial body, Earth was knocked out of its comfortable orbit? Imagine our world suddenly starting a slow, inexorable drift, either inwards towards the fiery furnace of the Sun, or outwards into the dark, frigid depths of space. Right now, on this day, August 3rd, 2025, our Earth is a masterpiece of cosmic engineering, perfectly tuned for life. The single most important feature, as we've mentioned, is liquid water. Oceans, lakes, rivers, and even the water vapor in our clouds create a global system that regulates temperature and supports countless ecosystems. This vast amount of water acts like a giant planetary-scale air conditioner. But it's not just about water. Earth has another secret weapon, its atmosphere. This blanket of gases does more than just give us air to breathe. It contains a delicate balance of greenhouse gases, like carbon dioxide and methane, which trap just the right amount of heat from the Sun. Furthermore, our atmosphere contains the ozone layer, a vital shield that absorbs most of the Sun's harmful ultraviolet radiation. This protection was crucial for life to move out of the oceans and colonize the land. Another feature that makes Earth so hospitable is its molten iron core, which generates a powerful magnetic field. This invisible force field, called the magnetosphere, extends far out into space and deflects the solar wind, a constant stream of charged particles blasted out by the Sun. Finally, think about Earth's tilt and rotation. Our planet is tilted on its axis by about 23.5 degrees. This tilt is what gives us our seasons. Our 24-hour day ensures that no single side of the planet faces the Sun for too long, which helps to distribute heat evenly. Now, let's start our imaginary journey and nudge Earth's orbit inwards, just a little bit closer to the Sun. What would happen first? The thermostat of our planet would begin to rise, slowly but relentlessly. A seemingly small shift in our orbit, perhaps moving us to where Venus is now, would have catastrophic consequences. The extra solar energy hitting our planet would mean warmer days and warmer nights. Glaciers and polar ice caps would start to melt at an unprecedented rate. This process would have a dangerous feedback loop. As the white ice disappears, it reveals the darker land or ocean beneath. Dark surfaces absorb more sunlight than white ice, which in turn warms the planet even more, causing even more ice to melt. As the planet heats up, the oceans would begin to warm as well. Warmer water can't hold as much dissolved gas, so vast quantities of carbon dioxide stored in the oceans would be released into the atmosphere, amplifying the greenhouse effect dramatically. But the real tipping point would come from the water itself. As the oceans heat up, more and more water would evaporate, filling the atmosphere with water vapor. Now, water vapor is a very powerful greenhouse gas, even more potent than carbon dioxide. The consequences for our planet would be apocalyptic. Global average temperatures would soar past the boiling point of water, reaching hundreds of degrees Celsius. The oceans, the cradle of life on Earth, would literally boil away into the atmosphere. In the early stages of this inward drift, before the oceans boil, life on Earth would face a desperate struggle for survival. The initial rise in temperature and changes in weather patterns would be devastating for most ecosystems. Coral reefs, the vibrant rainforests of the sea, would be the first to go. They are incredibly sensitive to temperature changes, and a sustained increase would cause mass bleaching events, turning them into ghostly white skeletons. As the temperatures continue to climb, only the most resilient forms of life would stand a chance. We might see the rise of extremophiles, organisms that thrive in extreme environments. Think of the thermophilic bacteria that currently live in hot springs like those in Yellowstone National Park. In the final hothouse stage, with the oceans boiled away and surface temperatures reaching hundreds of degrees, it's hard to imagine any life surviving on the surface. The intense heat and crushing pressure would sterilize the land. For humanity, the slow march towards the sun would trigger a global crisis unlike any other. The initial stages of warming would lead to worldwide social and political collapse. Coastal cities, home to billions of people, would be submerged by rising sea levels from the melting ice caps. Agriculture would fail on a massive scale as traditional farming lands turn to desert, leading to unprecedented famine and conflict over scarce resources like fresh water and arable land. To survive, humans would have to rely on technology as never before. We would be forced to abandon the surface of the planet and retreat into massive, self-contained habitats. These could be vast underground cities, burrowed deep into the rock to escape the searing surface temperatures. These subterranean arcs would need to be marvels of engineering, with closed-loop life support systems that recycle every drop of water and every molecule of air. Food would be grown in massive hydroponic and aeroponic farms under artificial lights. The long-term survival of our species would likely depend on leaving Earth altogether. The planetary-scale engineering required to build underground cities might be better directed towards constructing massive spaceships or generation ships. These vessels would be self-sustaining worlds in their own right, designed to carry thousands of people on a centuries-long journey to find a new home planet orbiting another star. Our home would become our tomb, and our only hope would be to become a truly spacefaring species. Now let's rewind and send our planet on the opposite journey. Imagine Earth's orbit begins to expand, pushing us away from the sun and out towards the orbit of Mars and beyond. The first thing we would notice is the cold. The global average temperature would start to plummet. The days would become dimmer, and the winters longer and more severe. Instead of a runaway greenhouse effect, we would face a runaway ice age. The polar ice caps would begin to grow, creeping down from the north and up from the south, locking more and more of the world's water into solid ice. As more of the planet gets covered in white ice and snow, more sunlight is reflected back into space. Eventually, the entire surface of the Earth could become encased in a thick shell of ice, a scenario scientists call a snowball Earth. We have evidence that this may have happened at least once in our planet's distant past. The atmosphere itself would begin to change dramatically. As the temperature drops, the air would become incredibly dry, as most of the water vapor would freeze and fall as snow. Eventually, it would get so cold that other gases in the atmosphere would start to condense. The sky would look different too. The sun, now more distant, would appear smaller and provide less light and warmth, casting a perpetual twilight over the frozen landscape. Without a significant atmosphere to scatter the light, the sky might become a dark, inky black, filled with brilliant stars even during the day. In a world spiraling into a deep freeze, life would be engaged in a desperate retreat. On land, as the ice sheets advance, forests and grasslands would be crushed and buried. Animals would be forced to migrate towards the equator, the last part of the planet to freeze over. This would create a shrinking, hyper-competitive zone of life, where predators and prey would be squeezed together in a final, brutal struggle for survival. Plants would struggle in the dim light and cold temperatures. However, life is tenacious. The oceans, even as they begin to freeze over on the surface, would offer the best hope for survival. The thick layer of ice on top would act like an igloo, insulating the water below from the extreme cold of the surface. In the deep ocean, near hydrothermal vents, life would carry on much as it does today. These vents spew out superheated, mineral-rich water from the planet's interior, creating oases of warmth and chemical energy on the dark ocean floor. As the oceans become darker and colder, some surface-dwelling species might adapt in incredible ways. Fish and other marine animals could evolve to produce natural antifreeze proteins in their blood, which would prevent ice crystals from forming in their cells. Life on a snowball Earth wouldn't be a spectacle of giant herds or lush forests, but a hidden, microscopic world. A testament to the sheer stubbornness of biology to survive against all odds. For humanity, a cooling Earth would present a different, yet equally dire set of challenges compared to a warming one. The initial stages would see the collapse of agriculture in the northern and southern latitudes, forcing a massive migration of populations towards the equator. This would lead to immense geopolitical instability, as nations in the tropics would suddenly have to support billions of climate refugees. The fight for the last remaining warm, arable lands would be fierce. Energy would become the most precious commodity. To survive in the long term, humans would again have to turn to technological solutions. We would need to build cities that could withstand the crushing cold. These cities would likely be built deep underground to take advantage of geothermal heat from the Earth's crust. Another, even more audacious idea would be to construct giant orbital mirrors. These immense, lightweight structures, positioned in space, would be designed to capture the faint sunlight and focus it onto specific areas of the Earth's surface, like giant magnifying glasses. Ultimately, just as in the warming scenario, the best long-term strategy would be to look to the stars. The immense technological effort required to live on a snowball Earth might be better spent on an exodus. Humanity would need to become a spacefaring civilization. Our frozen planet would serve as a stark and powerful motivator, pushing us to finally take our place not just as inhabitants of a planet, but as citizens of the cosmos. Exploring these extreme futures, from a boiling hellscape to a frozen wasteland, serves a powerful purpose. It highlights the extraordinary luck and the delicate balance that makes our existence possible. We live on a planet that is not too hot, not too cold, but just right. This perfect positioning in the Goldilocks zone, combined with a host of other fortunate circumstances like our atmosphere, our magnetic field, and our large moon, has allowed life to flourish in breathtaking diversity for billions of years. This journey of imagination also underscores the importance of scientific understanding. By studying other planets in our solar system like scorching Venus and frozen Mars, we get real-world examples of what can happen when planetary conditions go wrong. Understanding the principles of the habitable zone, the greenhouse effect, and planetary feedback loops isn't just academic. It's crucial for understanding our own world and the impact we are having on it. The resilience of life in these scenarios, from microbes in the clouds to creatures by deep-sea vents, offers a profound lesson in hope and tenacity. Life is tough. It clings on in the most unlikely of places, and humanity, with its unique capacity for foresight, technology, and cooperation, is perhaps the most resilient species of all. The challenges of surviving a planetary catastrophe showcase our potential for incredible ingenuity and adaptation. So the next time you step outside and feel the sun's warmth on your skin, or breathe in the fresh air, or see a rain cloud passing overhead, take a moment to appreciate it. You are experiencing the magic of a planet that is perfectly positioned in its habitable zone. Our home is a dynamic, beautiful, and fragile world. Understanding our place in the cosmos, the precariousness of our orbit, and the factors that make Earth special is not just for scientists and astronomers, it's for all of us. It fosters a sense of wonder, a deeper appreciation for our world, and a powerful sense of responsibility to protect this precious blue dot we call home.